simulated reality is the hypothesis that reality could be simulated for example by computer simulation to a degree indistinguishable from true reality. It could contain conscious minds which may or may not be fully aware that they are living inside a simulation. This is quite different from the current, technologically achievable concept of virtual reality. Virtual reality is easily distinguished from the experience of actuality. Participants are never in doubt about the nature of what they experience. Simulated reality, by contrast, would be hard or impossible to separate from true reality. There has been much debate over this topic, ranging from philosophical discourse to practical applications in computing. Types of simulation. Brain-computer interface . In brain-computer interface simulations, each participant enters from outside, directly connecting their brain to the simulation computer. The computer transmits sensory data to the participant, reads and responds to their desires and actions in return. In this manner they interact with the simulated world and receive feedback from it. The participant may be induced by any number of possible means to forget, temporarily or otherwise, that they are inside a virtual realm. While inside this simulation, the participant's consciousness is represented by an avatar, which can look very different from the participant's actual appearance. Virtual people. In a virtual people simulation, every inhabitant is a native of the simulated world. They do not have a real body in the external reality of the physical world. Instead, each is a fully simulated entity, possessing an appropriate level of consciousness that is implemented using the simulation's own logic. As such, they could be downloaded from one simulation to another, or even archived and resurrected at a later time. It is also possible that a simulated entity could be moved out of the simulation entirely by means of mind transfer into a synthetic body. Arguments. Simulation argument. The simulation hypothesis was first published by Hans Moravec. Later, the philosopher Nick Bostrom developed an expanded argument examining the probability of our reality being a simulacrum. His argument states that at least one of the following statements is very likely to be true. 1. Human civilization is unlikely to reach a level of technological maturity capable of producing simulated realities, or such simulations are physically impossible to construct. 2. A comparable civilization reaching aforementioned technological status will likely not produce a significant number of simulated realities for any of a number of reasons, such as diversion of computational processing power for other tasks, ethical considerations of holding entities captive in simulated realities, etc. 3. Any entities with our general set of experiences are almost certainly living in a simulation. In greater detail, Bostrom is attempting to prove a tripartite disjunction, that at least one of these propositions must be true. His argument rests on the premise that given sufficiently advanced technology, it is possible to represent the populated surface of the Earth without recourse to digital physics. That the qualia experienced by a simulated consciousness is comparable or equivalent to that of a naturally occurring human consciousness. And that one or more levels of simulation within simulations would be feasible given only a modest expenditure of computational resources in the real world. If one assumes first that humans will not be destroyed nor destroy themselves before developing such a technology, and, next, that human descendants will have no overriding legal restrictions or moral compunctions against simulating biospheres or their own historical biosphere, then it would be unreasonable to count ourselves among the small minority of genuine organisms who, sooner or later, will be vastly outnumbered by artificial simulations. Epistemologically, it is not impossible to tell whether we are living in a simulation. For example, Bostrom suggests that a window could pop up saying, "You are living in a simulation. Click here for more information." However, imperfections in a simulated environment might be difficult for the native inhabitants to identify, and for purposes of authenticity, even the simulated memory of a blatant revelation might be purged programmatically. Nonetheless, should any evidence come to light either for or against the skeptical hypothesis, it would radically alter the aforementioned probability. The simulation argument also has implications for existential risks. if we are living in a simulation, then it's possible that our simulation could get shut down. Many futurists have speculated about how we can avoid this outcome. Ray Kurzweil argues in The Singularity is Near that we should be interesting to our simulators, and that bringing about the singularity is probably the most interesting event that could happen. The philosopher Phil Torres has argued that the simulation argument itself leads to the conclusion that, if we run simulations in the future, then there almost certainly exists a stack of nested simulations, with ours located towards the bottom. Since annihilation is inherited downwards, any terminal event in a simulation above ours would be a terminal event for us. If there are many simulations above us, then the risk of an existential catastrophe could be significant. Relativity of reality equals, as to the question of whether we are living in a simulated reality or a real one, the answer may be indistinguishable, in principle. In a commemorative article dedicated to the World Year of Physics 2005 physicist Bin-Guang Ma proposed the theory of relativity of reality. The notion appears in ancient philosophy, Zhuangzi's butterfly dream, and analytical psychology. Without special knowledge of a reference world, one cannot say with absolute skeptical certainty one is experiencing reality. Computationalism. Computationalism is a philosophy of mind theory stating that cognition is a form of computation. It is relevant to the simulation hypothesis in that it illustrates how a simulation could contain conscious subjects, as required by a virtual people simulation. For example, it is well known that physical systems can be simulated to some degree of accuracy. If computationalism is correct, and if there is no problem in generating artificial consciousness or cognition, it would establish the theoretical possibility of a simulated reality. However, the relationship between cognition and phenomenal qualia of consciousness is disputed. It is possible that consciousness requires a vital substrate that a computer cannot provide, and that simulated people, while behaving appropriately, would be philosophical zombies. This would undermine Nick Bostrom's simulation argument. We cannot be a simulate consciousness, if consciousness, as we know it, cannot be simulated. However, the skeptical hypothesis remains intact. We could still be inverted brains, existing as conscious beings within a simulated environment, even if consciousness cannot be simulated. Some theorists have argued that if the consciousness as computation version of computationalism and mathematical realism are true, then consciousness is as computation, which in principle is platform independent, and thus admits of simulation. This argument states that a Platonic realm, or ultimate ensemble, would contain every algorithm, including those which implement consciousness. Hans Moravec has explored this simulation hypothesis and has argued for a kind of mathematical Platonism according to which every object can be regarded as implementing every possible computation. Dreaming. A dream could be considered a type of simulation capable of fooling someone who is asleep. As a result, the dream hypothesis cannot be ruled out, although it has been argued that common sense and considerations of simplicity rule against it. One of the first philosophers to question the distinction between reality and dreams was Zhuangzi, a Chinese philosopher from the 4th century BC. He phrased the problem as the well-known butterfly dream, which went as follows. Once Zhuangzi dreamt he was a butterfly flitting and fluttering around, happy with himself and doing as he pleased. He didn't know he was Zhuangzi. Suddenly he woke up and there he was, solid and unmistakable Zhuangzi. But he didn't know if he was Zhuangzi who had dreamt he was a butterfly, or a butterfly dreaming he was Zhuangzi. Between Zhuangzi and a butterfly there must be some distinction. This is called the transformation of things. The philosophical underpinnings of this argument are also brought up by Descartes, who was one of the first Western philosophers to do so. In Meditations on First Philosophy, he states, "There are no certain indications by which we may clearly distinguish wakefulness from sleep," and goes on to conclude that it is possible that I am dreaming right now and that all of my perceptions are false. Chalmers discusses the dream hypothesis, and notes that this comes in two distinct forms, that he is currently dreaming, in which case many of his beliefs about the world are incorrect. That he has always been dreaming, in which case the objects he perceives actually exist, albeit in his imagination. Both the dream argument and the simulation hypothesis can be regarded as skeptical hypotheses. However, in raising these doubts, just as Descartes noted that his own thinking led him to be convinced of his own existence, the existence of the argument itself is testament to the possibility of its own truth. Another state of mind in which some argue an individual's perceptions have no physical basis in the real world is called psychosis, though psychosis may have a physical basis in the real world and explanations vary. Computability of physics equals. A decisive refutation of any claim that our reality is computer simulated would be the discovery of some uncomputable physics, because if reality is doing something that no computer can do, it cannot be a computer simulation. Introduces other possibilities which will be dealt with separately. In fact, known physics is held to be computable, but the statement physics is computable needs to be qualified in various ways. Before symbolic computation, a number, thinking particularly of a real number, one with an infinite number of digits, was said to be computable if a Turing machine will continue to spit out digits endlessly, never reaching a final digit. This runs counter, however, to the idea of simulating physics in real time. Known physical laws are very much infused with real numbers and continua, and the universe seems to be able to decide their values on a moment-by-moment basis. As Richard Feynman put it, "It always bothers me that, according to the laws as we understand them today, it takes a computing machine an infinite number of logical operations to figure out what goes on in no matter how tiny a region of space, and no matter how tiny a region of time. How can all that be going on in that tiny space? Why should it take an infinite amount of logic to figure out what one tiny piece of space-time is going to do?" So I have often made the hypothesis that ultimately physics will not require a mathematical statement, that in the end the machinery will be revealed, and the laws will turn out to be simple, like the checkerboard with all its apparent complexities. The objection could be made that the simulation does not have to run in real time. It misses an important point, though. The shortfall is not linear. Rather, it is a matter of performing an infinite number of computational steps in a finite time. Note that these objections all relate to the idea of reality being exactly simulated. Ordinary computer simulations as used by physicists are always approximations. These objections do not apply if the hypothetical simulation is being run on a hypercomputer, a hypothetical machine more powerful than a Turing machine. Unfortunately, there is no way of working out if computers running a simulation are capable of doing things that computers in the simulation cannot do. The laws of physics inside a simulation and those outside it do not have to be the same, and simulations of different physical laws have been constructed. The problem now is that there is no evidence that can conceivably be produced to show that the universe is not any kind of computer, making the simulation hypothesis unfalsifiable and therefore scientifically unacceptable, at least by Popperian standards. All conventional computers, however, are less than hypercomputational, and the simulated reality hypothesis is usually expressed in terms of conventional computers, that is Turing machines. Roger Penrose, an English mathematical physicist, presents the argument that human consciousness is non-algorithmic, and thus is not capable of being modeled by a conventional Turing machine type of digital computer. Penrose hypothesizes that quantum mechanics plays an essential role in the understanding of human consciousness. He sees the collapse of the quantum wave function as playing an important role in brain function. Can't go to environments equals. In his book The Fabric of Reality, David Deutsch discusses how the limits to computability imposed by Gar-paragraph-Dell's incompleteness theorem affect the virtual reality rendering process. In order to do this, Deutsch invents the notion of a can't-go-to environment, using Cantor's diagonal argument to construct an impossible virtual reality which a physical VR generator would not be able to generate. The way that this works is to imagine that all VR environments renderable by such a generator can be enumerated, and that we label them VR1, VR2, etc. Slicing time up into discrete chunks, we can create an environment which is unlike VR1 in the first time slice, unlike VR2 in the second time slice, and so on. This environment is not in the list, and so it cannot be generated by the VR generator. Deutsch then goes on to discuss a universal VR generator, which as a physical device would not be able to render all possible environments, but would be able to render those environments which can be rendered by all other physical VR generators. He argues that an environment which can be rendered corresponds to a set of mathematical questions whose answers can be calculated, and discusses various forms of the Turing principle, which in its initial form refers to the fact that it is possible to build a universal computer which can be programmed to execute any computation that any other machine can do. Attempts to capture the process of virtual reality rendering provides us with a version which states, it is possible to build a virtual reality generator, whose repertoire includes every physically possible environment. In other words, a single, buildable physical object can mimic all the behaviors and responses of any other physically possible process or object. This, it is claimed, is what makes reality comprehensible. Later on in the book, Deutsch goes on to argue for a very strong version of the Turing principle, namely, it is possible to build a virtual reality generator whose repertoire includes every physically possible environment. However, in order to include every physically possible environment, the computer would have to be able to include a recursive simulation of the environment containing itself. Even so, a computer running a simulation need not have to run every possible physical moment to be plausible to its inhabitants. Nested simulations equals, the existence of simulated reality is unprovable in any concrete sense, any evidence that is directly observed could be another simulation itself. In other words, there is an infinite regress problem with the argument. Even if we are a simulated reality, there is no way to be sure the beings running the simulation are not themselves a simulation, and the operators of that simulation are not a simulation. Recursive simulation involves a simulation, or an entity in the simulation, creating another instance of the same simulation, running it and using its results. Peer-to-peer explanation of quantum phenomena equals, in two recent articles, the philosopher Marcus Arvin has argued that a new version of the simulation hypothesis, the peer-to-peer simulation hypothesis, provides a unified explanation of a wide variety of quantum phenomena. According to Arvin, peer-to-peer networking inherently gives rise to quantum superposition, quantum indeterminacy, the quantum measurement problem, wave-particle duality, quantum wave function collapse quantum entanglement, a minimum space-time distance, and the relativity of time to observers. In fiction, simulated reality is a theme that predates science fiction. In medieval and Renaissance religious theatre, the concept of the world as theatre is frequent. Simulated reality in fiction has been explored by many authors, game designers, and film directors. See also Major contributing thinkers Jean Baudrillard, Nick Bostrom and his simulation argument, Rena Copyright Descartes and his evil demon, sometimes also called his evil genius, Philip K. Dick for We Can Remember It For You Wholesale, George Berkeley and his immaterialism, Stanislaw Lem who presented the idea for example in further reminiscences of I Jean-Tiki part of the Star Diaries, Plato and his allegory of the cave, Zeno of Elea, Zhuangzi and his Chinese butterfly dream. Bibliography, Copleston, Frederick, 1946. 19 Theory of Knowledge. A History of Philosophy, Volume I, Greece and Rome. New York, Image Books. Pages 160. ISBN 0-385-46843-1. Copleston, Frederick, 1960. To Descartes. A History of Philosophy, Volume 4, Modern Philosophy. New York, Image Books. Pages 86. ISBN 0-385-47041-X. Deutsch, David. The Fabric of Reality. London, Penguin Science. ISBN 0-14-014690-3. Lloyd, Seth. Programming the Universe, a Quantum Computer Scientist Takes on the Cosmos. Knopf. ISBN 978-1-4000-4092-6. Tipler, Frank. The Physics of Immortality. Doubleday. ISBN 0-385-46799-0. Lem, Stanislaw. Summer Technology. ISBN 3-518-37178-9. References. External links. Anthropic-principle.com website maintained by Nick Bostrom with a collection of papers on ESA and related topics. The Big Brother Universe, Computer Universes and an Algorithmic Theory of Everything by Jawan Kortara G. N. Schmiduba, The Computational Requirements for the Matrix Discussion on Slashdot. Computationalism, The Very Idea, An Overview of Computationalism by David Davenport. The Cutting Edge of Haptics, an article in MIT's Technology Review on Touch Illusion Technology by Duncan Graham Rowe. God is the Machine Wired article by Kevin Kelly. That Mysterious Flow. Davis, Paul, Set Scientific American 287, 40–45. Simulated Universe paper by Brent Silby provides objections to the simulation argument. The Simulation Argument website by Nick Bostrom, Director, Future of Humanity Institute, Oxford University. Includes his original paper. Simulation, Consciousness, Existence by Hans Moravec. Simulism, a wiki devoted to the possibility that our reality is a simulation. Superhumanism, an interview of Hans Moravec by Charles Platt. What We Still Don't Know, Channel 4 documentary by British astronomer Royal Sir Martin Rees. Zombies, a Euro-philosophical zombie article by Robert Kirk in the Stanford Encyclopedia of Philosophy.